Listen, there is a specific kind of silence that haunts the floor of a locomotive works when the engineers realize they have pushed the laws of thermodynamics just a bit too far. A heavy, metallic quiet that feels like the calm before a boiler explosion. In April 1936, the Henschel works in Kassel weren't quiet. They were a cacophony of ambition, the rhythmic hammering of steel on steel, echoing the desperate heartbeat of a nation trying to outrun its own logistical nightmares. As the spring thaw softened the ground outside the factory gates, and the first buds of the season began to appear on the trees lining the Fulda River, a monster was being birthed in the shadows of the assembly hall. This was a machine that wasn't meant to be an experiment or a stopgap, but the ultimate translation of German engineering into fire and motion. This was the Baureihe 45. It stood there, a mountain of black-painted iron, with 10 coupled driving wheels, 3 massive cylinders, and a boiler designed to withstand over 20 bars of pressure, a figure that at the time felt less like a technical specification and more like a dare to the gods of steam. Those who saw it for the first time didn't need a blueprint to understand that the rules of the rail had changed, because the German Reichsbahn was facing a simple, brutal math problem that no amount of optimism could solve. The trains were getting heavier, the schedules were tightening like a noose, and the grades of the main lines were becoming insurmountable barriers to the standard fleet. The Unified Locomotive Program, which had been the backbone of the rails for a decade, had finally hit a wall in the form of the Baureihe 44. The 44 was a workhorse, a reliable beast that did its job well, but on the arterial lines where 1,000 tons of freight needed to be moved without the costly delay of double-heading or pusher engines, it was gasping for air. The Reichsbahn needed an instrument that could do the work of two, a singular apex predator of the rails that could settle the equation once and for all. The answer they drafted was technically arrogant, a 1E one-wheel arrangement that promised more stability at high speeds than the 2-10-0 configuration of its predecessors, featuring a trailing truck designed to keep the massive frame steady as it tore through the countryside. The goal was laid out in cold, hard numbers: 1,200 tons on level track at 80 kilometers per hour, or 1,000 tons up a 0.5% grade at 60. These were figures that looked impressive on vellum paper, but felt like madness to the men who actually had to forge the steel. Henschel & Son, a house that had been building the iron pulse of Germany since 1848, took the contract. But even for them, the Class 45 was a departure from reality. The tolerances were tighter, the time frames were shorter, and the complexity of the 3-cylinder arrangement meant that every single component had to be perfect, because at 20 bars of pressure, there is no such thing as a minor mistake. By the time the first prototype, works number 22805, rolled onto the tracks as 45-001, the air of spring was filled with the scent of coal smoke and the realization that they had built something that might just be too powerful for the world it was meant to inhabit. They had created a masterpiece of thermal efficiency on paper, featuring a Belpaire firebox and 300 square meters of heating surface. Yet tucked away inside that magnificent boiler was a fatal flaw waiting for the first sign of weakness. The cedar roar, the boiler tubes, stretched 7.5 meters long, a distance that challenged the very physics of water circulation and invited the kind of material fatigue that turns a locomotive into a ticking clock. But in those early days of 1936, as the sun began to warm the rails for the new season, nobody wanted to talk about fatigue. They only wanted to talk about the power that was about to be unleashed on the Mannheim to Basel line. The pressure inside the design offices at Kassel was mounting long before the first fire was ever lit in the 45's massive firebox. Because in the mid-1930s, the Reichsbahn wasn't just buying locomotives. They were buying a statement of national industrial supremacy. For Henschel & Son, the stakes were higher than mere profit. Their reputation as the premier locomotive builder of the continent was on the line, and the technical specifications handed down from the central office in Berlin were nothing short of a declaration of war against the limits of metallurgy. Every meeting was a battlefield of shop politics, where engineers argued over the weight distribution of the 1E1 frame and the precarious decision to use ST47K steel, a high-tensile, silicon-alloyed material that promised incredible strength for less weight, but carried a hidden, brittle temperament that few dared to voice in public. The accountants were breathing down the necks of the draftsmen, horrified by the soaring costs of the three-cylinder arrangement and the complex valve gear, while the Reichsbahn bureaucrats demanded a machine that could maintain the frantic pulse of a nation rearming in total silence. There was a desperate underlying tension in the air as the timetable for the series production was moved up, forcing the factory to bypass long-term stress testing in favor of immediate results. This wasn't just about moving freight, it was about proving that German steam could outperform the burgeoning diesel and electric threats that were beginning to appear on the horizon. The prestige of the 45 was so great that failure was considered a form of industrial treason, yet the engineers knew they were walking a razor's edge with the boiler design. To reach that mythical 20 bars of pressure, they had to push the heating surfaces to the absolute limit, resulting in a boiler so long and a firebox so vast that it challenged the physical capabilities of a human crew. In a move of staggering short-sightedness driven by weight restrictions and budget cuts, the decision was made to omit a mechanical stoker, a piece of equipment common in North America for engines of this size. This meant that to keep the beast fed, two firemen would have to work in perfect, grueling synchronicity, shoveling tons of coal into a white-hot maw for hours on end just to keep the pressure needle from dropping. It was a brutal solution to a technical problem, placing the burden of the machine's success squarely on the backs of the men in the cab. As 1940 approached and the order for 26 series machines was finally greenlit, the atmosphere in the castle works shifted from creative ambition to a grim assembly line urgency. The world was changing, the shadows were lengthening over Europe, and the Class 45 was no longer just a triumph of engineering. It was a heavy-duty tool of logistics that had to perform perfectly or risk the collapse of the very schedules it was built to maintain. The reputation of every man at Henschel was now bolted into those frames, and as the first of the series engines, 45-003, began to take shape, the quiet whispers about the fragility of the ST47K steel were drowned out by the roar of the factory floor. They were committed to a design that was as expensive as it was powerful, a machine that required a level of maintenance and operational precision that the coming years would make almost impossible to provide. Inside the belly of the 45 lay a technical spine designed to crush the geography of southern Germany, yet it was this very skeleton that would eventually fracture under its own ambition. The machine was a three-cylinder symphony of motion, featuring one internal cylinder driving the cranked axle and two external ones working in a staggered rhythm. This configuration was intended to provide a near-constant torque, a smooth application of power that turned the iron rails into a conveyor belt for the heavy industry of the Ruhr. On the grueling runs between Mannheim and Basel, the 45 didn't just pull trains, it dominated them, churning out over 3,000 indicated horsepower, a figure that placed it in a league of its own, an apex predator of the European rail network. But this immense power came at a price that wasn't measured in Reichmarks, but in thermal stress and metallurgical fatigue. The boiler was a masterpiece of over-engineering on paper, boasting a massive grate area and those infamous 7.5-meter tubes. The theory held that this extreme length would extract every possible calorie of heat from the exhaust gases. But in the reality of the field, physics fought back with a vengeance. The water circulation near the front of the boiler was sluggish, creating lethal temperature differentials that tore at the very seams of the ST47K steel. This wasn't a gradual wearing down. It was a violent structural rebellion. The long tubes would begin to bow and leak, and the firebox, the white-hot heart of the locomotive, would develop hairline fractures that could turn a routine freight haul into a catastrophic failure of pressure. To keep the 45 from tearing itself apart, the maintenance shops were eventually forced to perform a technical retreat, lowering the operating pressure from the ambitious 20 bars down to a safer 16. It was a mechanical lobotomy, stripping the engine of the peak performance that was its sole reason for existence, turning a revolutionary machine into a compromised giant. Then there was the reality of the cab, a place where the industrial dream met the limits of human endurance. Because the designers had omitted a mechanical stoker to save weight and complexity, the 45 became a human-powered furnace. Two firemen had to stand shoulder to shoulder in the cramped, shaking space of the footplate, swinging heavy shovels in a choreographed dance of total exhaustion. They had to move tons of coal every hour just to keep the pressure needle from bottoming out, working in a heat that felt like a physical weight. If one man slowed down, the train stalled on the grade. If they both pushed the engine to its limit, the temperamental steel of the boiler threatened to crack. It was a machine that demanded the absolute maximum from both metal and man, creating a failure mode that was as much about human biology as it was about mechanical engineering. The 45 was a victim of its own reach, a locomotive that required a perfect world of high-grade coal, elite maintenance, and superhuman crews, none of which would survive the coming years. By the time the flaws were fully understood, the shop fixes were no longer about refinement, but about survival. As the engineers realized that their masterpiece of castle was possessed of an Achilles heel made of the very steel that was supposed to make it invincible. The 45 was powerful, yes, but it was a brittle power. A giant that could haul the world, but couldn't withstand the heat of its own heart. In 1945, the dust settled on a landscape of twisted iron and broken dreams. And for the Class 45, the myth of the invincible super locomotive was finally dragged into the cold light of a divided reality. Of the 28 machines that had been built to conquer the continent, most were found sitting cold in bombed-out sheds or abandoned on sidings, their grand ambitions reduced to rusting paperwork and leaking seals. The official records of the Deutsche Bundesbahn in the West and the Reichsbahn in the East told a story that contradicted the propaganda of the 1930s. While the 45 was undeniably the most powerful steam engine Germany had ever produced, it was also the most temperamental. The paperwork didn't lie. The 44, its simpler predecessor, was the one moving the nation's recovery, while the 45 sat in the shops waiting for specialized parts that no longer existed. In the West, the DB attempted a bold reversal of fortune, a final effort to justify the existence of these giants by stripping them down and rebuilding them with what they should have had from the start. 5 machines, including the legendary 45-010, were fitted with completely new welded boilers and, crucially, the mechanical stokers that had been omitted years before. For a brief moment, the myth seemed to align with the record. These rebuilt 45s became the undisputed kings of the heavy freight runs, hauling massive ore and coal trains with a reliability they had never possessed in their original form. Witnesses spoke of their thunderous exhaust and the way they seemed to shrink the hills of the Ruhr. But the ledger books of the 1950s told a different story. Even with the new boilers, the 45s were expensive, complex, and demanded a level of specialized maintenance that the cash-strapped DB could ill afford. Meanwhile, in the Soviet occupation zone, the story of engine 45-024 took a turn toward the surreal. In 1951, East German engineers decided to push the 45 beyond the limits of sanity, converting it into a high-pressure experimental locomotive designated H45-024. They pushed the pressure to a staggering 42 bars, double the original design, in a desperate bid for thermal efficiency that ignored the basic laws of mechanical endurance. It was a failure of epic proportions. The high-pressure cylinders leaked, the condensers failed, and the machine spent more time as a stationary object of study than a functioning locomotive. By 1959, the East had given up on the dream, scrapping the experiment and salvaging what remained for the construction of the legendary 18201. The grand reversal was complete. The machine built to lead a 1,000-year rail empire was being cannibalized to build something else entirely. The paperwork of the late 50s reveals a sobering truth that many rail enthusiasts hate to admit. The 45 was a masterpiece of what-if engineering, but in a world that needed to move millions of tons of coal every single day, the record favored the simple, the rugged, and the boringly reliable. The 45 was a ghost of a future that never arrived, a myth captured in the black and white photos of test runs, while the real work of history was being done by the very machines it was supposed to replace. As the 1960s drew to a close, the thunder of the Baureihe 45 was fading from the German landscape, replaced by the hum of electric motors and the drone of diesel engines. By November 1968, the last of the unmodified Class 45s was pulled from the roster without a whisper of ceremony. There were no flags, no speeches, just a cold firebox and a final signature on a decommissioning form that consigned a legend to the past. Most of these three-cylinder monsters were sent directly to the cutting torch. Their high-tensile steel, which had once promised to withstand the fury of 20 bars of pressure, sold off by the ton to be melted down. Only one machine, the 45-010, escaped this fate, and it wasn't due to a grand preservation plan or a sudden burst of sentimentality from the railway board. It was saved because the Bundesbahn's central office in Munich needed its massive weight and unique braking characteristics for scientific testing and dynamometer runs. It spent its final years as a sophisticated tool for the very engineers who were designing its replacements, a mechanical ghost haunting the testing tracks of a new Germany. Eventually, it was moved to the Nuremberg Transport Museum, becoming the sole survivor of a class that was supposed to have changed the face of European freight. For decades, it sat as a silent, static giant in the shadows of the roundhouse, until the morning of October 17, 2005. The fire in the Gostenhof district was a tragedy that rail historians still discuss in hushed, somber tones. It was one of the most devastating disasters in the history of industrial heritage preservation, as 24 legendary vehicles were engulfed in an inferno that reached temperatures high enough to melt glass. The 45-010 was at the heart of that fire, and when the roof of the roundhouse finally collapsed, the locomotive was left as a charred, blistered ruin. The damage was catastrophic, with many experts believing that the giant had finally met a fire it couldn't survive. But the decision to restore it was a testament to the fact that some machines represent the very soul of an era. Between 2008 and 2012, at the Mining and Steam Locomotive Works, a miracle of industrial archaeology took place. New boiler plates were cut and welded with modern precision. The massive driving wheels were realigned, and the complex three-cylinder heart was meticulously cleaned of the soot and trauma of the fire. By April 2012, the 45-010 moved under its own power once again for its post-restoration trials, a sight that brought tears to the eyes of those who remembered the golden age of steam. Today it stands as a restored monument in the DB Museum in Nuremberg, a black and red titan that no longer has to struggle with the grades of the Black Forest or the exhausting demands of its own firebox. It is important to recognize that popular history often compresses the reality of these machines into a mythic narrative of perfection, but the truth is more complex. The 45 was a logistical nightmare that was outperformed in every practical, everyday sense by the simpler and more rugged Baureihe 44. It was too expensive, too demanding of its crews, and too brittle for the harsh realities of wartime and post-war reconstruction. It stands today not because it was the most successful engine ever built, but because it was the most ambitious. It is a physical question cast in iron. Was the pursuit of the absolute technical limit worth the price of its own fragility? The 45-010 is the final witness to a time when we believed that enough coal, enough pressure, and enough steel could conquer any distance. History is written by the machines that work day after day without complaint, but it is remembered through the ones that dared to push until they broke. If you could bring one other lost class of locomotive back from the scrap heap for just one more run, which engine do you think truly deserved a second chance?